All right. And to end off this section, we're going to take a look here at a couple different ideas. Specifically here for the sake of time, I'm going to leave examples number 6 and example number 7 as one for you to go ahead and try to work through on your own. We've already briefly talked about some of these ideas, but you can take a look at these examples in the notes online if you don't want to try to experiment with them on your own. But they're here to just kind of highlight that we've already done some change of variables this semester when we've talked about things like cylindrical coordinates and spherical coordinates and polar coordinates. We've already dealt with this idea, and so we should be able to understand the idea behind Jacobians and these transformations and things related to them. So I won't go through example 6 right now, but I will go ahead and at least take a look very quickly here at the fact that we can kind of extend this notion of a Jacobian and this new change of variables idea to even triple integrals. So here's what we got. Suppose that t is a transformation that takes something from u v w space to xyz space. And maybe it does it in the following way. First formula spits out an x, second formula spits out a y, last formula spits out a z. If the first order partials of the component functions of t are continuous, then we can say that the Jacobian would be the 3/3 determinant given by the following. So again, the Jacobian is a very important thing that we need in order to be able to kind of correct when we do one of these change of variables. And here we'll see that the setup of this is extremely similar to the setup of the 2×2 matrix setup that we had in the double integral case. So you'll notice here that across this first row, I'm kind of again writing out the gradient for that g function, the partial of it with respect to u, and then v, and then w. And I'm going to have the same thing as I go with the y formula. And finally, the exact same thing when I go with the z formula. And I would compute this determinant here using exactly the process that we discussed back at the very beginning of the semester of doing a cross product. So again, I can extend this notion one dimension higher. If you take a look then down at the fact that I have below, so I can say using similar hypotheses to the change of variables for a double integral, it is possible to prove a theorem for the change in variables for a triple integral. And ultimately, it would say the following. If I wanted to integrate, say, over b of some function of 3 variables, then I can, again, imagine changing out all of the individual pieces. One of the first things I would have to change is I would have to change out my functions. So I'd have to say, I'm going to replace x with a function of u's, v's, and w's. I'm going to replace y with the functions of u's, v's, and w's. Same with z. Once my function's changed, I'm also going to want to change my region over, and therefore change my bounds. I'm also going to have to kind of at the back have like a du, dv, dw. All my differentials are going to have to change. But also before that, I'm going to need absolute value of my Jacobian, but my Jacobian from 3 space. Oops, looks like up above in my box I had a slight typo. You'll see here I used z twice. That should definitely be a w. My apologies. Okay, like I said, I'm not going to go ahead and go through example number 6 or example number 8 here, or sorry, example number 7, but I will leave it to you to try to go ahead and take a look at those examples on your own. They're not something that I would ask you to do in an exam or on a homework, but I think that they can be at least helpful to shed some light on how exactly these definitions work and why exactly we're interested in extending to 3 cases, or the third dimensional case. Specifically, we can use that when we talk about things with spherical coordinates and understand a little bit more about where that rho squared sine phi came from when we talked about the change of variables in that section. All right, well, that pretty much concludes everything that we have here for section 4.7. You really are going to need to make sure that you go back to the textbook and you try to do a bunch of examples out of this section. Without trying to practice a whole bunch of this, this can be a very weird section to get used to. So make sure that you're trying to break down these problems bit by bit, and the more practice you have, the more questions you ask, the better you'll be at it. All right, I'll see you in 4.8 in the next set of videos.